Everybody. In this video, we're going to be talking about ratios and what a ratio is. So when you're looking at ratios, the basic idea is that you're comparing two amounts, and specifically you're looking at the multiplicative relationship between those two amounts. So there's three different types of ratios. The first one is a part-to-part ratio. And an example of this would be saying that there's one adult for every four children. And so the reason this is called a part-to-part ratio is because the whole group of people, like if you had a whole group of people, some of them would be adults, some of them would be children. And in this case, we're comparing the multiplicative relationship between the number of adults and the number of children. And so we're comparing the two parts of the entire group. You can also have part-to-whole ratios, like one of every six children is wearing blue. So in this case, the one is talking about the part of the group of children that's wearing blue, and the six is talking about the entire group of children that includes the children who are wearing blue as well as the children who are not wearing blue. So that would be a part to whole ratio. And then the last type of ratio you can have is a rate. So a rate is a special type of ratio where the units are different. So for example, you could say I can bike 10 miles every hour. If we look at the units of this, we have miles and hours, and the relationship between them is that you can bike 10 miles for every 1 hour. Versus if we look at part to part and part to whole ratios, in these cases, we're talking about the same units because you have one adult for every four children. Well, the units are that you are talking about people. It's the same type of units. Same thing with a part to whole. If you have one of every six children is wearing blue, you have one child for every six children. So a rate is a special type of ratio where the units are different. One thing to note is that fractions are usually thought of as part to whole ratios. Like if you're thinking about the fraction 2/3, usually the way that we think about it is that the denominator, the 3, tells you how many parts there are in a whole, and the numerator tells you how many parts you're focusing on, like how many shaded parts you have. But you can sometimes use fractions to represent part to part ratios and rates as well. So when we're notating ratios and we're writing them out, there's several different ways we can do this. So let's say that we have 2 apples for every 3 oranges. We could say that the ratio of apples to oranges is 2 to 3 written with a semicolon, or you can write it out in words as 2 to 3, or you can write it as a fraction like this. The important thing is whatever word comes first, that needs to come first in your notation. Whatever word comes second, that's going to be second in your notation. And that's just important so that we know which numbers correspond to which objects. So now let's talk about equivalent ratios. So if I had the statement that I drove 200 miles in 4 hours, I could write this as a rate, and I could say that I'm driving 200 miles for every 4 hours. So I'm going to write this as a fraction, but you could also use any of the other notations as well. And so this ratio is telling me the relationship or the multiplicative relationship between the distance that I drive and the amount of time that it takes for me to drive that distance. And technically, I should call this a rate because the units are different. So an equivalent ratio is a ratio or a rate that describes the same multiplicative relationship, but you may have different numbers. So if I drove 200 miles in 4 hours, an equivalent ratio would be driving 400 miles in 8 hours because the relationship or the multiplicative relationship between these two numbers is still the same. Because I basically just doubled the amount of time, but I also doubled the distance. And so one way you could think about this rate is you could think about it as a speed. Whether I go 200 miles in 4 hours or 400 miles in 8 hours, the speed that I'm traveling is the same. And this brings us to the idea of a reduced ratio or a simplified ratio. And the idea of a simplified ratio is you just make the numbers as small as possible. So in this case, because I can divide 204 by 4. They both have that as a factor. I'm going to say another equivalent ratio would be going 50 miles in 1 hour. Because if I split up the 200 miles into 4 equal sized groups, that will be 50 miles. And if I split up the 4 hours into 4 equal sized groups, that's 1 hour. And so this ratio is an equivalent ratio to the 200 miles in 4 hours ratio. But it's considered fully simplified because the numbers are as small as possible. And this is basically just like reducing fractions, because ratios and fractions are very related to each other. So one way that you can help your students see equivalent ratios is with set models. So let's say on School Spirit Day, 15 students were wearing red and 20 students were wearing yellow. And we want to find the simplified ratio of students who wore red to students who wore yellow. So I have a whole bunch of dots here. And if I was teaching this to elementary school students, I might have little counting chips or some type of physical objects. And I would have 15 wearing red and 20 wearing yellow. And what we would want to do is we would want to see if we could arrange these in a way that we can have equal sized groups that have the same balance of red to yellow in them. So I've kind of already done this for us. And if you arrange all those red and yellow dots, it's possible to create an array that looks like this. And so you can say, okay, this array represents the ratio of having 15 students who are wearing red to 20 students who are wearing yellow. And the balance between students who are wearing red and wearing yellow should also be written as 3 to 4. Notice that 15 divided by 5 equals 3 and 20 divided by 5 equals 4. And so this would be an equivalent ratio that represents the same multiplicative relationship. Now, there's also lots of other equivalent ratios, like you could say that there are 6 students who are wearing red for every 8 students who are wearing yellow. Or you might say that there's 9 students who are wearing red for every 12 students who are wearing yellow. All of these ratios would be equivalent, but this one is the simplified one. And so this is an example of how you can use set models to help your students reduce ratios or simplify them. And the reason why this is useful is because if you have smaller numbers that are representing the multiplicative relationship, then they're more versatile and you can find all of the other ones. Like, for example, doing 3 times 5 and 4 times 5 gives you the 5 to 20 ratio, but you could go 3 times 2 and 4 times 2 to get the 6 to 8 ratio. Or you could do 3 times 3 to get 9, 4 times 3 to get 12. So all of these other ratios can be expressed from the simplified ratio. But if you wanted to go from, say, like the 15 to 9, you would have to multiply by a fraction, which still technically works, but it's a little bit more difficult. And so that's the reason why simplified ratios are useful. One thing to note is when you're doing set models with physical objects, there are often many different ways that your students might arrange the arrays. So, for example, if you had 12 cups of blue paint that you're representing with 12 little counter chips or something like that, with 18 cups of green paint, if he's mixing these cups of paint to paint his room and we want to find the ratio of blue to green paint, there's lots of different arrays that are equivalent to 12 to 18. Like you could say that you have 4 to 6. That would be an equivalent ratio. Or you could say that you have 6 to, I think that's 9. That would also be an equivalent ratio. Or you could say that an equivalent ratio would be 2 to 3. All of these ratios are equivalent, but this one is the most simplified because the two parts of the ratio do not share any common factors. So that's the basic idea of a ratio and how you can use set models to help your students visualize the ratios, as well as how to reduce the ratios to the most simplified form. So I hope this video was helpful. If you have any questions, let me know.